Okay, for problem number 2 on our first review at the end of our chapter 12 unit, it says you've got function e to the negative x. And this is so very, very important to point out that they're asking for a Taylor polynomial with degree 3, but guys, you're going to notice that you will need to be told every single time where you're centered. That cannot just be left unsaid. The worst case scenario is when they just say Maclaurin series. They're still telling you where you're centered. If you don't know where you're centered, you can't do a problem like this. Okay, so they're saying here's e to the negative x. Find a Taylor polynomial centered at c equals 1. Now, at this point, I do want to make a quick comment about what I have at the top of the screen. So very often, kids will correctly say, hey, haven't we memorized a series for e to the x? I'd say most definitely, we did. And in fact, we just did a homework problem together where we did that. And you could see I've written it out up the top. I didn't write the nth term, and that's fine. But then kids will say, this is so cool. We're centered at c equals 1. So sometimes kids will do one of two things. They'll say, ooh, I get it. Everywhere where you see an x, just plug in negative x. Would that give you a Taylor series centered at c equals 1? No. It wouldn't. You'd still be centered at 0. Sometimes kids will say, how do you know that? How do you know that? Well, you still would have like x minus 0 to the third. Kids will say, oh, I know how to fix that. I'm going to just, everywhere where we see an x, I'll plug in x minus 1. And kids will say, I remember that. You got to, be centered right there. Would that fix the problem? No, because then you'd have to do it on the left. So we are not able, I don't want kids to be surprised that this Maclaurin series that we memorized up here, yes, it's powerful. Yes, it's wonderful. It helps you out a ton, but it's not like your silver bullet that always comes to your rescue. It's not this panacea. So in any event, you'd say, well, I've got to make this Taylor polynomial. My goodness, what do I need to do? We have to generate it the old-fashioned way, step by step. You could say, well, look, I'm going to have f of x. That's equal to e to the negative x. You could say, well, if I'm centered at 1, that means I'm going to be plugging in a 1. Yes. Very quickly, you could see you've got 1 over e. And then you could say, well, you better take a derivative. We have to go out to a third degree. Derivative. Ooh, so very often kids will say, easy. Derivative of e to a function is e to a function. Ooh, chain rule, yes. Derivative of negative x is negative 1. Out comes a negative. Kids will say, well, you still are centered at 1. You plug in a 1. Yes. Definitely. This becomes negative 1 over e. And then we could say, well, let's take a second derivative. We could do that. As we take our second derivative, we bring down this negative 1 yet again with another chain rule. The negative e to the x now becomes a positive e to the negative x. We're going to plug in a 1. And we're back to e to the negative 1. It doesn't take long for kids to say, wow, it sure looks like we're in a general pattern right here. With the derivatives and what we get by plugging in a 1. Take another derivative. The chain rule is going to bring a negative out. And hey, oh, forgive me, I meant to write f triple prime of x. And then, of course, as we plug in a 1, we'd get negative e to the negative 1, which is just a negative 1 over e. Sometimes kids will say, oh, this is so great, I'm going to stop now. Well, from what we saw yesterday, we saw that you're not done. If you're working out to the third degree, yes, you need the third derivative. But the Lagrange error bound will always say, go one step beyond. Go one step beyond. You'll take your fourth derivative. Kids will say, well, with the chain rule, that's just e to the negative x. Yes. And then kids will say, now plug in a 1. No. We're plugging in, yes, we're going to plug in z. And this is the abstract, strange, weird situation. Kids look at that, they'll say, z? What's z? We don't know. We just don't know. But we do know that z is between where we are centered, which is 1, and whatever we are evaluating, which we will have as x. So z is some unknown value between 1 and x. Wow. Well, that's just our preliminary starting point. Now what? Well, they want us to make a third-degree Taylor polynomial. Well, the way we generally write that is p sub 3. P for polynomial. The subscript of 3 says, I'm going out to the third power. The highest power of x you'll see is a 3. And kids will say, okay. Let's talk about this in general. You'd say, well, I'm centered at 1, so I should have f of 1 plus f prime of 1, x minus 1 to the 1 over 1 factorial, plus f double prime of x, the second derivative, plug in a 1 right there. We'll have x minus 1 to the second power all over 2 factorial. You remember that pattern. The power of x is going to match the factorial down below. You've got a 2 up high, you got a 2 down low, you're going to have a second derivative. Last thing, you're going to say, now I'm going to go to my third derivative, evaluated where I'm centered, and I'll have x minus 1 to the third divided by 3 factorial. And now we can get some help. We can say, well, what was f of 1? Well, f of 1, you can see in that little table off to the side, it's right here. You'd say, well, that was 1 over e. And they could say, what about f prime of 1? Well, that was negative 1 over e. You could very well just write this out in this regard. You know, x minus 1 to the first, of course, is just what we have. F double prime of 1, you could say, well, that's again 1 over e. And then you've got 2 factorial, that's a 2. So that's 1 over 2e, and this is x minus 1 squared. Dividing by 2 is the same thing as multiplying by a half. And finally, the third derivative evaluated at 1, you can see that's all the way down here. That's your negative 1 over e. 3 factorial, though, is 6. So I've got a negative out in front, so I could say it's negative 1 over 6e, and here's x minus 1 to the third. Guys, that's your third degree polynomial that could be used to estimate e to the negative x when you're centered around 1. Okay? But they're also saying, now, wait just a minute. That's great that you did that. But we'd also like to talk about error. We'd like to talk about the Lagrange error bound. The Lagrange error bound was written as R3 of x. And if you're going out to that third degree, that's where we're going to say, oh yeah, that's where we take our fourth derivative evaluated at z, and then we'll have x minus 1 to the fourth all over 4 factorial, and things are working out. But you could say, well, what is that fourth derivative when you plug in a z? You'd say, well, I get 1 over e to the z. So my error is going to be x minus 1 to the fourth. 4 factorial is really 24. And I also have this e to the z that got moved down below. That is your error. Okay? And guys, at that point, you've really worked out what part A is. Okay? We doing okay so far? Okay, so it's very much like what you were doing in 1210. You know, it's just that you're going to stop at a designated power, And then you're going to say, if I ever use this to evaluate, what exactly are we talking about for error? So that's part A. We're done with part A here. But part B says, now use that polynomial to approximate e to the negative 1.02, and then show that you're actually going to have an error that's pretty small. It's smaller than 0.5 times 10 to the negative 4th. Think, my word. Well, what's happening for part B? They're saying, here's the function e to the negative x. And they're saying, would you please approximate e to the negative 1.02? Now, I do want to point something out to you. Your x then has to be 1.02. Okay, so I'm going to say we're going to let x equal 1.02. I'm trying to approximate that thing, and I'm going to say this is about what p sub 3 of 1.02 is going to get me. And you can think, well, what is that p of 1.02? Well, you know what? It's at the top of the screen here. It's this thing, guys. But I'm going to plug in 1.02. It's this thing right here. So, tell you what, I'm going to get the calculator out. You do the same, okay? Let's get our calculator out. Okay, so I brought my calculator back up. Sorry for the delay, but we're going to take this function at the top of the screen, and we're going to say plug in 1.02 into it. You can see I've done that right here as we had the video paused for a moment. And that might be one of those little time-consuming parts of the problem that just make this problem a little bit longer. But you can see what I've done. I've got wherever there was an x, I replaced it with 1.02. You hit enter. You could say, well, it sure looks like we're at about 0.360594. Okay, so it looks like 0.360594. And you could say, well, hey, that's about what e to the negative 1.02 is. And at this point, you can say, well, okay, that's good, I guess. That's a pretty good estimate. Somebody would say, well, how do you know how good the estimate really is? Let's talk about error. And guys, this is the very last part. Your error is going to go back to the Lagrange error bound. Your error has to be less than R3 of 1.02. And you can see R3 is, just up in here. You can say it's going to be the absolute value of 1.02 minus 1 to the 4th. And down here I've got this 24e to the z. And again, you look at that, you think, what in the world is z? Z is between where you are centered and what you are evaluating. You're trying to estimate what's happening at 1.02, but you're centered at 1. Now, guys, right now you should choose one of these two to finish up your estimate. And you want to maximize your error. Your e to the z is in the denominator. To maximize a fraction, to make a fraction the largest it can be, make your denominator as small. We're going to choose z equals 1. Say why? Well, I want this denominator. And by the way, 0.02 minus 1, 1.02, that's just going to be 0.02 to the 4th. Down here, I'm going to have 24e to the 1. We're going to get that calculator back out. And you can see where we're going with this. We're going to divide by, I need parentheses here, 24. I'm going to go second divide. Oops, I goofed that up. Here, we got to say divided by parentheses 24e. And then you get 2.45 times 10 to the negative 9. which is less than what we're asked to have.